student, welcome to CHEM-O-HOLIC. Today we are going to start a topic which is a grade 10 topic. The name is acid, bases and acid, alkali and the salt. Basically the salt is also going to come in this. So acid, alkali and salt, we are going to introduce the topic, but before starting this topic, let me clear one thing, that we should be aware about the terminology which we are using under the acid basis concept. Okay, so and in this video is a very basic video about the acid and alkali. Under this video I will tell you what are the basic terminology and what are the terms involved in acid and bases, which we have studied in grade 8 and grade 9. So this video will be the compilation of videos, the previous standards, the standards like 8th and 9th. After this video, after getting this foundation for our knowledge, we will go on the next and we will go into detail. So this video will cover main learning objective of this video is what to know the solution can be sorted whether they are acid, alkali or neutral. Means by studying this video you will be able to conclude that a given solution or given substance is acid, basis or neutral. Okay, even to understand that an alkali react with an acid to cancel it out. Okay, we will understand here that acid will cancel out the alkali. Cancel out the alkali means what? It react and it neutralize it. So we are going to understand the neutralization reaction as well. To know that the indicator, we are going to learn about the concepts of indicator and what are the responses of indicator in terms of acid as well as bases. Even we are going to discuss the response of indicator in case of neutral. So let's begin the topic, and again I will tell you the same thing. Please take your notebook and pen to note down the important terms. Okay, so let's start this session. Okay, the term comes acid and alkali. Okay, acids and alkali, they're very common terms. Okay, so we are listening, we are getting this word in our day-to-day life. We are listening from household items and all. We are listening from our friends as well. So acid and alkali, what is acid? Acid, when a substance dissolve in water, it makes a solution. When any substance dissolve in water makes a solution. Let me clear one thing. What do you mean by solution? The question arises over here. What do you mean by solution? Solution is it's mixture. Can I say it's a mixture? Obviously I can say it's a mixture. Solution is a mixture. Solution is not a compound. Why it is not a compound? Because when two substance A and B, two substance are mixed together, they are forming they can be mixed in two ways. One is what? In regular in a specific composition, or we can say they are mixed in a specific ratios, and another is what? In any random proportions, or in any not specific proportion, it's any random proportion. So when they are mixed in a specific proportion, they form a compound. They form compound. Okay, and the compounds are formed new substance. It means, like, suppose if AB is forming, right? So AB is totally new than their A and B. It means what we can say? The property of the new substance is totally new than the respective element. But in case of mixture, the AB will form means new compound will not form. First thing. Second thing is what? It will be like whatever the component, whatever the mixture will form, their property will remain, their respective elements property will remain as it is. It is not going to change. It means you can separate the mixture by simple physical process, and you cannot separate the compound by simple physical processes. So that is what A and B is there, which is a mixture. This mixture are of the two types. This mixture is of the two types. What are the types? We can say homogeneous mixture and heterogeneous mixture. Mixture are of the two types: homogeneous mixture and heterogeneous mixture. If it is a homogeneous mixture, homogeneous mixture and heterogeneous. Okay, so in case of homogeneous mixture, what is the homogeneous mixture? Homogeneous mixture are the mixture when a plus b means two component are mixed together, they are giving a single phase. If they're giving us out a single phase, so they can be called as a homogeneous mixture. What we can call it as a single phase? Single phase means what? Their state will be single state, either they will be liquid, either or they will be solid, or they can be gases, any phases it may be, but their phases will be only single phase, so they will be considered as a homogeneous. Okay, homogeneous mixture. And heterogeneous mixture, we can have a heterogeneous mixture means two different phases. Let's have the example of it. In case of homogeneous we can have, suppose if I'm having a glass of water adding salt. Okay, so what I'll get, the salt will get dissolved, I'm going to get a solution that is called as a salt solution. I'm going to get a mixture of salt and water which is containing only one phase, that is a liquid phase. No more solid you will be able to see, means that will be considered as solution. So what do we mean by solution? Solution is a something which is homogeneous mixture. Solution is something what? It's a homogeneous mixture, they contain single phase. That is clear? Okay, after that the heterogeneous is a mixture. So under this acid and base concept, we are going to see the terminology. One terminology I told you, that solution is something which is dissolved in water. So the word the statement which is written over here, when a substance dissolve in water it makes solution, it means they should dissolve, they should give one single phase, so they will be called as a solution. Solution can be whatever the solution, whenever the solution you are preparing, any salt solution, sugar solution, or any acid solutions, or any, suppose if you are making the juice, lemon juice if you are making, or you are making the sugar juice, sugar solutions, or you are making the salt solution, any solution whichever you are making, they are having their own nature. Every solutions are having their own nature. They can be acid, they can be alkali, or they can be neutral. Let me clear once again. I told you what is solution. Solution is a homogeneous mixture of two or more substance. When one substance is dissolved in another, giving out a single phase, can be called as a solution. So these solution, whichever solution we are talking now, the solutions are, they may be possibly, they may be acidic, they may be alkali, or they may be neutral. Okay, you must have heard the word that is base. Sometime you in your chapter it may have written that acid, base and salt. Instead of alkali they have written the bases. What is difference between base and alkali? That's a big question. I can say alkalis are water soluble bases. Alkalis are what? They are water soluble bases. And bases are there insoluble bases, very simple. So you can classify the bases on the basis of solubility: water soluble bases and water insoluble bases. Water soluble bases are those bases like which solubilize in water, and such bases are called as alkali. We have a very good example: potassium hydroxide, that is KOH, and NaOH are the wonderful example for the same. Okay, I think it is clear. That is water soluble bases and bases. Okay, so the terms we are going to use is what? The acid, alkali, or neutral. These terms are there. Okay, so after this, okay, when the oxide of some non-metals, see, we have studied the non-metals and metals forms oxides, metals and non-metals, when they undergoes combustion, non-metal also undergoes combustion, means treated with oxygen. Metal also undergoes combustion. See, a word combustion, whenever a word combustion comes, first of all things comes in our mind, that is we are going to burn something, we are going to like burn something, combust something. Okay, so that is exactly same, the combustion is the same, like we are going to burn something, but we are going to burn in presence of oxygen. So what will happen whenever the metal burn, combust in presence of oxygen? It does not mean that we are keeping for heat or something. It's not like that way. It means that we are combusting, we are, when metal come in contact with oxygen, Okay, when metal comes in contact with oxygen, undergoes oxidation, forms metal oxide. Same way, non-metal undergoes combustion, it forms non-metal oxide. Very simple, metal oxide and non-metal oxide. The nature of non-metal oxide and metal oxide are we are going to study. So when the oxide of some non-metal, when the oxide of some non-metal dissolve in water, they make an acid. So you can make it out, non-metal oxides are acidic in nature and metal oxides are basic in nature. So you can note it out, metal oxides are basic in nature and non-metal oxides are acidic in nature. This is one term, way to make out the acids. Okay, so how we can make out the acid? We can say then when oxide of some non-metal dissolve in water, they will give out the acid. Okay, non-metal reacting with oxygen gives oxide. Which oxide? Non-metal oxide. When they are reacting with water, it will gives out acid. So there you can see the steps which is mentioned over here. Non-metal oxides, non-metal react with oxygen, combustion, undergoes combustion, gives out the non-metal oxide, which is treated with water to give the acid. Okay, that is one process to identify the acid. If it is non-metal oxide, they will be acidic in nature. We have many non-metal oxide, we have many non-metal oxides, you can see. Okay, now we have one more terms, that acid have sour in taste. Acid is sour in taste, means this is the property of acid. Acid is sour in taste and they are corrosive in nature. First of all, the question may arise in your mind, can we taste all the acid by tongue? It's very difficult, it's corrosive. That's why the next point you need to study, you need to see this next point. Next point says that they are corrosive. So if you are tasting with your tongue, it will be very harmful to you. So what you can do, just like that for dilute acid they have given, like if you want to test citric acid, like which is present in lemon, or ascorbic acid which is present in oranges, if you'll test it, tartaric acid which is present in tamarind. Okay, so if you'll test them, these acids are generally they are sour in taste. So you can conclude one thing, that acids are sour in taste and they are corrosive in nature. So you can make out the acids are corrosive in nature and they are sour in taste. One more thing, you may say that acids are sour in taste, that is okay, but are all acids are corrosive? Definitely not. All see, if the acids are in more concentration, the concentrated acids are corrosive, the concentrated acids are corrosive, the dilute acids are not at all corrosive. We are using lots of acid in our daily life, in our food. We are using ascorbic acid, oxalic acid, we are using even lactic acid in the milk, we are using tartaric acid. Many acids we are using in our daily life, and those acids are organic acid, and generally organic acids are non-corrosive in nature, they are not corrosive in nature. So if you are eating ascorbic acid, citric acid or other acid, they are organic acid. If they are organic acid, they are not corrosive in nature. So you can conclude one thing, only the more concentration, more corrosion. Keep in mind that more concentration, more corrosion. That is one part for acid. Okay, after that, acid react with metal. That is one more terms. Acid react with metal and carbonate. Metal and carbonate. See how the acid show the reaction. So there are the two reaction I have mentioned over here. Acid react with the metals as well as acid react with a carbonate. React with a metal and react with carbonate. Okay, so if we'll talk about the metal, acid react with a metal. If acid reacting with a metal, they will form salt and hydrogen gas will liberate out. This is an activity. This is an activity which is given already in the chapter number 1. If you'll see the zinc powder in a hydrochloric acid solution, if you're putting the zinc metal, what will happen? The hydrogen gas is coming out. Okay, so hydrogen gas is coming out. A zinc chloride solution will form. So basically what we are getting here, the metal reacting with acid will form salt and hydrogen gas. So what we are concluding from here, we can conclude that if this is forming salt, if the reaction forming salt, it means this is acid. So obviously this may be acting as a base. So metal is acting as a base here, and in this case what will happen when you are reacting with acid, it will form salt and it will liberate out the hydrogen gas. You can see the one example is given over here. I have taken the zinc rod here, I have taken the zinc rod, and you can see the hydrochloric acid is taken in this. Okay, so if the zinc rod or zinc dust is put in the hydrochloric acid, you can see the bubbles of gas is coming out, and that is what hydrogen gas. Hydrogen gas. Now the big question arises again, sir, how you can say this gas is a hydrogen gas? Generally students ask that how you can say the hydrogen gas, this gas is a hydrogen gas. So I can say, I will take the burning splint. I will be take the burning splint near the this gas, and I'll be getting the pop sound. Suddenly I'll be getting the pop sound. So this pop sound like indicate that there is a presence of hydrogen gas. This test is called as a confirmatory test. So this test is called as what? Confirmatory test, which confirms that the which gas is present in that. Okay, so basically again let's revise the things. What I said, the metal plus acid means metal react with acid, it forms salt and hydrogen. It forms salt and hydrogen. Metal react with acid, forms salt and hydrogen. Generally you can say take the mineral acids like hydrochloric acid, sulfuric acid, you can take nitric acid, you can take, they will show. Okay, here the example they have taken. Another example we can see over here. Already I explained you with the help of zinc. If you are taking instead of that magnesium ribbon, if you are taking the magnesium ribbon for that, so magnesium ribbon, that is magnesium treating with hydrochloric acid, you will be getting magnesium chloride. You will be getting the magnesium chloride, which is a salt, and hydrogen gas will come out. Again I'm telling you how to find the hydrogen gas with the help of pop sound. So many time you will come across that to check whether the gas is carbon dioxide gas or oxygen gas or nitrogen gas, or which gas is coming out. If you want to check it, you can check with it, like if it is giving us pop sound, you can say it is a hydrogen gas. Okay, if the splint is get extinguished, if the burning splint get extinguished, you can say that that is a carbon dioxide gas present. Okay, so the many processes are there. If the burning splint is continuously, it is start burning more fast, or we can say the gas which is supporting to the burning, now that gas can be considered as the oxygen gas. Okay, so that is the process. That was one reaction. Another reaction we can see, the acid plus carbonate gives us salt, water and carbon dioxide. Acid plus carbonate gives salt, water and carbon dioxide. So what is this you can make out the acid. So this, if this is acid and this is giving us salt, I told you acid plus base always gives salt and water. See, it is not always the water. I will explain in the next terms whenever it will come to Arrhenius acid and Arrhenius base theory and all. As I told you, this is an introductory video. After that, once I am making the video on, I will be making a video on complete describing the acid and bases, and I will take you in the depth. So here we can say that acid with base gives us salt and water. So you can say over here acid plus base gives us salt and water. So you can say carbonate is acting over here as a base. Okay, so we can say the salt and water are forming, and once the salt and water are forming, the gas which will evolve out, that gas is carbon dioxide gas. We can have an example, sulfuric acid treated with a copper carbonate. If I am treating the sulfuric acid with copper carbonate, this copper and this sulfuric acid will form copper sulfate, and water will form, and the gas which will come out, that is carbon dioxide gas. So how you'll make out the carbon dioxide gas is that. Okay, so I told you, if you are bringing the burning splint near the mouth of the test tube, if this is a test tube and the gas is coming out, if you'll bringing near to the mouth of the test tube, you will be getting the splint will get extinguished. Why it is getting extinguished? Because of the carbon dioxide gas. Okay, that is one part. So this was the basic reaction. Let's revise again this reaction. As I told you, metal plus acid gives us salt and hydrogen. One thing, metal plus acid gives us salt and hydrogen gas. Hydrogen gas will liberate out. We have many examples for this. Acid carbonate, if it will react with carbonate, you are going to get the salt, water and carbon dioxide. Okay, this was the very basic reaction. Okay, but what are the where do we use acid in a daily life? As I told you, acids, there are many acids present in our everyday lives. There are many acids which are present in our everyday life. We are using in the lemon juice contain, as I told you, citric acid. Vinegar contain ethanoic acid. Some strong acids are hydrochloric acid, sulfuric acid and nitric acid. Some weak acid are also there, that is what, ethanoic acid, citric acid and carbonic acid. As I told you, these weak acids are non-corrosive in nature, and the ethanoic acid, these weak acids are non-corrosive in nature, and these strong acids are corrosive in nature. But only the thing is what, they should be concentrated, they should not be dilute. If they are diluted, they will be not corrosive in nature. Okay, there is one more terms comes, that is neutralization reaction. What do we mean by neutralization reaction? Neutralization reaction means what? They are making out neutral. Like for example, A was acidic and B was base. Okay, so here the nature of basic is too much. Okay, here acidity is too much. What will happen when they are reacting together? They are neutralizing each other, they are neutralizing each other, and the AB which will come out, they will be neutral. Okay, so what is neutralization? Neutralization is a reaction in which acid and alkali, okay, neutralization is a reaction in which the acid and alkali react with each other. Acid and alkali react with each other. The alkali cancel out the acid in the reaction. Okay, the cancel out, here the word cancel out means they what they do, alkali cancel out the acid. It means they are neutralizing the acid in the reaction, and this process, this reaction is called as a neutralization reaction. So make sure the neutralization reaction is a reaction is always between the acid and bases. Neutralization reaction is always between the acid and bases. So what we can say, acid and alkali react together, they are giving us salt and water, they are giving us salt and water. So keep in mind that. Okay, hydrochloric acid, which is acid, sodium hydroxide, which is base, once they are reacting, they are giving us sodium chloride and water molecule. Once they are reacting, they are giving us sodium chloride and water molecule. A salt is made. Okay, so as I discussed the two things, acid and alkali was on the top. Now what is the salt? Salt is the product of acid and bases. Salt is a product of acid and bases. When they are neutralized, when there is a neutralization reaction happen between acid and bases, they are forming salt and water. See, again and again I'm telling you, they will not form water always. There are many reactions, they will only form salt, they will not form water. What are those reactions that I told you I am going to discuss in the next video and upcoming video, and when I'll be explaining about Arrhenius theory of acid and bases, Bronsted-Lowry theory of acid and bases, and Lewis theory. Whenever I'll be explaining this theory, then I'll be dealing with those. Now hydrochloric acid with sodium hydroxide gives us sodium chloride. That is one reaction and one example I gave to you. Okay, so this was the neutralization reaction. After that, the salt, as I told you, salts are what? Salts are made depend on the acid and alkali use. Salt made depend on the acid and alkali use. The salt contain the metal from the alkali and the part of acid molecule. So what we can say, first point, if you'll see, salt made depend upon the acid and alkali used. Okay, see, very simple, salt made, whatever salt is made is totally depend upon the acid and alkali use. How much quantity of acid you are using, how much quantity of bases you are using. Suppose I told you acid and bases which are mixed, you are giving us AB, which is a salt. Okay, so can any amount of the salt, can any amount of acid, and can any amount of base can be mixed? Can any concentration of acid and can any concentration of base can be mixed? No, we can't. We have to ensure that how much quantity of acid, with what concentration of acid and bases we should mix. There is a proper proportion. That's why this statement says, the first statement says, that is what a salt made depend on the acid and alkali use, and the salt contain the metal atom from the alkali and the part of acid molecule. So it contain whatever the metal atom or anything, it is a part of acid molecule. The salt of sulfuric acid is known as sulfate. The salt of hydrochloric acid is known as chloride. The salt of nitric acid is called as a nitrate. So keep in mind that salt of sulfuric acid, if you are preparing this salt of sulfuric acid, that will be called as a sulfate. The salt of hydrochloric acid called chloride. Like for example, hydrochloric acid treated with magnesium for magnesium chloride, so magnesium chloride is the salt. Copper oxide treated with sulfuric acid, or copper carbonate treated with sulfuric acid, it will form copper sulfate as a salt. So that will be a salt, okay. And the copper, which is, I'm taking the metal, here magnesium, I'm taking the metal, or silver nitrate, Ag, if I'm taking the metal, whichever the metal are there, that metal is a part of alkali. Okay, that will be the part of alkali. We are taking the part of alkali. Okay, that is one part we should keep in mind that. So I think salt is clear. I explained what is acid, what is base, and what are the salts. Okay, and what is the neutralization reaction. Now in case of alkali, if I'll go into little more detail about alkali, so I can say alkalis are many everyday substance we are using as alkali. We feel soapy, the soaps are alkali, they are corrosive in nature. Again, they are corrosive. Again, you will say, sir, all alkalis are corrosive. No, the same answer will be as same as the acid we gave. When the oxide of the some metal dissolve in water, they make an alkali solution. They make an what? Alkali solution. Alkali react with acid and neutralize them. Alkali react with acid and neutralize them. The reaction is called as what? Which reaction? Please revise. The reaction is called as neutralization reaction. Okay, so when acid and bases react, they are giving neutralization reaction. Again, I'll tell you over here, earlier in the previous example I gave, the metal react with non-metal, react with oxygen, forms non-metal oxide, which was acidic. Now here metal oxygen, metal and oxygen, it gives us metal oxide, and this reaction is called combustion reaction. Combustion reaction. What is combustion reaction? Again, I'm telling, metal react with oxygen. When metal react with oxygen, is form the combustion reaction. Not only the metal, any material, any element which react with oxygen to form the oxide of that will be called as a combustion reaction for that. Now oxide, after that oxide, if you treat with water, you will getting the alkali. Okay, it's just the ulta of the previous reactions. I hope it is clear, right? So acid alkali is there. Alkalis are present in many cleaning substances used in our home. Kitchen cleaners are alkaline because they contain ammonia or sodium hydroxide, which attack the grease. Okay, so generally kitchen are oily. We are using oil, ghee, daldas, and other things we are using in our kitchen. So our kitchen is usually oily. To fight with oil, we are using the such detergent or such substances which contain ammonia or sodium hydroxide, which attacks the grease and which cleans out. Okay, you must have heard about the Vim liquid, Vim gel, Vim bar, etc. We are using for that. Okay, even we are using choline and other Lysol and all we are using for cleaning. This all they are the basic in nature. calcium hydroxide and sodium hydroxide are the strong alkalis. Calcium hydroxide and sodium hydroxide are strong alkali. The most recognizable and the common weak alkali is ammonia. Ammonia is the most widely used weak acid. Keep in mind that they are most widely used weak acid. Now you must be have worrying about what is the basis, on what basis we are classifying the strong alkalis and weak alkalis. So let me clear about the strong alkalis and weak alkalis can be classified on the basis of their solubility. So once you are putting into the water, if they are ionizing more, if they are getting dissociate more, so they will be called as a strong. For example, suppose if I'm taking 500 moles of any soil or substance, 500 moles of any base and putting in water, all 500 moles are getting dissociated into their ions, will be called as a strong alkali. And if they are not dissociating, only few moles are dissociating, will be calling as a weak. So make sure that weak and strong we are classifying on the basis of dissociation solubility. Okay, so that is one thing. Indicator, what is indicator? Indicator is the substance which indicate, indicator will help you to find, which will indicate the substance, the given substance is acid or not, which will indicate the acid or not, or it is acid or which substance. Like we are, you must have heard about litmus paper. We are using the blue color litmus paper and red color litmus paper. They change their color in acid or alkali solution. Different indicator change to different color. Okay, so indicator is one substance which indicate the acidity or basicity of the substance. Okay, so there are the many indicators, there are the many indicator, various types of indicator. There are acidic indicator, basic indicator, as well as some universal indicator. There are some natural indicator also that we are going to discuss in the detail in the upcoming video. And we will conclude this session today. In this session, what we discuss about what is acid, what is bases, and what are the alkali. Even we discuss about that how the reaction will occur and what are the conditions for the reaction. Even we discuss about what are the nature of metal oxide and non-metal oxide. Metal oxide, again revising, metal oxide is basic in nature, non-metal oxides are always acidic in nature. There the neutralization reaction occur, and we also saw the reaction between metal and acid, and metal and carbonate, where the carbonate was acting as a base, and in case of acid, if we treat with a metal, they were forming the they were liberating the hydrogen gas. And even we discuss about the detection test, confirmatory test of carbon dioxide and hydrogen gas. So these all topics we discuss. I will request to you all, please revise this topic and be ready for the upcoming video. In the upcoming video, I'll be dealing with this same topic but in more detail, which will be covering your grade 10 CBSE portion completely. Even I will give you many example for the reactions, so you will be make out that which reactions are for which processes. Even I'll be giving you some questions to you at the end of the video, so that you will be able to do it for your assessment. Okay, thank you so much for being wonderful audience, and I will request to you all, please like and subscribe my channel if you like this video. Thank you so much.